This is the Mathematics Education Podcast from mathedpodcast.com.
Welcome to the Math Ed Podcast. My name is Chuck Munter, an assistant professor of mathematics education at the University of Missouri. As recent listeners know, this year we've decided to create a new kind of episode to periodically include in the feed, one that is more of a digest of several recent research studies rather than an in-depth interview focused on just one. This new format is modeled in part after the old journal, Investigations in Mathematics Education. Published quarterly from 1968 to 1988, that journal offered expanded abstracts and critical analyses of recent research. To help translate that idea into podcast form, we extended an invitation to all listeners to become contributors who submit brief summaries and interpretations of recent works that they are interested in. In this third digest episode, we offer three such summaries. First, Jeremy Strayer will describe a recent study by Doerr and colleagues on a modeling approach to the development of students' informal inferential reasoning, published in the November issue of Statistics Education Research Journal. Next, I will summarize an article about teaching for spatial justice written by Rubel and colleagues, published in the last issue of the 2017 volume of the Journal of the Learning Sciences. Finally, on a bit of a different note, Sam Otten will provide a review of a recent book by applied mathematician David Acheson entitled The Calculus Story, A Mathematical Adventure. As it turns out, we'll be featuring a second kind of work from Dr. Acheson, as he graciously allowed us to use his instrumental guitar recordings for this episode's bumper music. We hope you enjoy this third digest episode, and as always, welcome suggestions and contributions from listeners.
I'm Jeremy Strayer from Middle Tennessee State University, and today I'm sharing a summary of the article, A Modeling Approach to the Development of Students' Informal Inferential Reasoning by Doerr, Robert DelMas, and Katie Makar. It was recently published in the Statistics Education Research Journal, Volume 16. This work was funded by grants from the Australian Research Council and the University of Queensland. The article begins by noting agreement among statistics education scholars that teaching informal statistical inference provides students with a holistic and coherent environment in which to learn. This is because informal statistical inference is based on predictions, something that people do every day. It's also based on our personal contextualized experiences, and it's focused on important big ideas and processes in statistics. The authors then build on this foundation using the notion that good mathematical models capture simplicity in relationships, generalizability in structure, and applicability in making sense of authentic problems. They claim that if modeling is an everyday classroom experience, it can be used as a primary vehicle for students' statistical learning. Rather than learning a set of rules and content, teachers can guide students to focus their efforts on developing adequate and productive models that can be used and reused in a variety of contexts. To this end, the authors envision instruction unfolding as what they term model development sequences. These sequences begin with, first, a model eliciting activity that brings out students' initial ways of representing and using mathematics to model a complex, realistic, and meaningful problem. This model eliciting activity is then followed by a series of model exploration activities that allow students to think about and modify, if necessary, the models that they created, and model application activities that ask students to think with their models and to adapt them to fit similar contexts. This all sounds nice, but can model development sequences truly support students in developing generalizable models? Well, that is precisely the question this study aims to answer. To that end, the authors conducted a design experiment with 25 Year 5 students in Australia who were 10 to 11 years old. Analyzing student work products and transcripts of classroom teaching and learning, the researchers identified 5 milestones that occurred during the 3-day instructional sequence. These milestones provided explanatory power for how the model development sequence supported students in developing their generalizable model and how the teacher orchestrated the elements of the classroom to enable this to occur. The experiment began with a model eliciting activity that asked students how long a helicopter that was constructed with a strip of paper and a paperclip could stay in the air. This is where the first milestone was reached. Namely, the teacher and students did significant work that attended to the variation in the collected data. This naturally led to the next milestones that were reached during a model exploration activity, where the class collectively represented their evidence, investigated how drop height matters, and identified useful characteristics of representations for comparing groups using dot plots. The final milestone occurred when students completed a model application activity where they applied their model in order to determine how big of a difference there is between the flight duration of short-wing and long-wing paper helicopters. This study is a great example of how a design experiment research study can produce results that directly inform practice. The results provide empirical descriptions of the ways the teachers and the students authentically engaged in a model development sequence of activities, and that those activities produce generalizable and usable models. As such, this study provides clear evidence that model development sequences can allow students to apply what they know to new problems as they complete coherently sequenced activities that attend to foundational statistical concepts and processes.
Hello, this is Chuck Munter again from the University of Missouri with a summary of a recent article in the 26th volume of the Journal of the Learning Sciences entitled Making Space for Place, Mapping Tools and Practices to Teach for Spatial Justice. The authors are Lori Rubel from Brooklyn College and Maren Hall-Wieckert and Vivian Lim from the CUNY Research Foundation in Brooklyn. Their report takes us into a 10th grade class in a New York City public high school for a couple of weeks in the fall of 2014, during which the students engaged in a learning design the authors titled Cash City, a 10-session module for high school students around the theme of what they refer to as a city's two-tiered personal finance system. In the module, students used a series of mapping tools to explore relative distributions across neighborhoods of New York's 5 boroughs of 2 types of financial institutions, banks and alternative financial institutions such as pawnshops, check cashers, or wire transfer outlets. The underlying concern is that alternative financial institutions cater to lower-income neighborhoods in predatory ways through high interest rates. As the authors argue, however, a complementary critique is that banks, supported by the legacy of redlining around race and class and by more recent practices around lending, do no better at meeting the needs of people with limited income. The school in which the study was conducted is in a neighborhood that, at the time, had a 31% poverty rate and a 9.4% unemployment rate. The student population had been identified by the district as 76% Hispanic and 21% African American, with about 20% classified as English learners and also about 20% identified as needing special education. The authors point out, however, that despite having several of the markers typically considered negative, the school's community surveys and parent and student opinions were consistently favorable. The teacher with whom the research team collaborated in the design was a white woman in her 8th year of teaching. It was her 10th grade advisory class in which the curriculum module was piloted with her 16 students. A primary focus of the paper are the learning opportunities afforded by a set of spatial tools which, the authors argue, have the capacity for interdisciplinary social critique that involves mathematics. These tools included Geographic Information Systems, or GIS maps, an oversized floor map on which students could walk, and participatory mapping in which students walked the school's neighborhood and collected media which were then aggregated and displayed on the GIS web mapping tool. In this case, learning is defined in terms of political formation, that is, deepening politicization with respect to individual experiences of exclusion or unequal access, viewing inequities or injustices from collective perspectives, and creating shared political knowledge. In this way, the authors frame their analysis as responding to increasing calls in learning sciences for more attention to the roles of race, power, and inequality. In their lit review, they first spend time framing learning as political formation, for which they employ ideas from critical geography and the learning sciences, and then position learning as political formation relative to literature on learning critical mathematics. The authors acknowledge a number of prior studies in the critical mathematics vein that attend to spatial distribution of resources, but argue that the role of place remains untheorized in these social systems under investigation and in subsequent analyses of learning. The authors also note some previously established cautions related to place-based learning, including that because of familiarity with place, learners can overprivilege prior knowledge, and that, quote, learning about the spatial analysis of data without an accompanying interrogation of race and power can be counterproductive and reinforce deleterious stereotypes, unquote. Of the 10 sessions, the first 4 focused on introducing how pawnshop and bank transactions and loans operate, including how they are different. In the next 3 sessions, students interacted with both the floor and digital maps to examine distribution of the 2 types of financial institutions in relation to population demographics. The 8th session was an extended opportunity for students to conduct participatory mapping of the financial institutions in the school's neighborhood. And the final 2 sessions were devoted to creating storyboards to present what they had learned, drawing evidence from the digital maps. All of the sessions were observed and audio recorded. Additionally, the floor map and participatory mapping days were video recorded, and 6 of the students' on-screen work and talk with GIS maps were captured with video and audio. For each session, the authors wrote analytic memos, attending to students' questions, ways of engaging with the maps, and noted in particular whether and how the students talked about race. In their analysis, the authors focused on A, how learners engaged with the set of spatial tools, and B, evidence of political formation. For the former, they developed codes through a grounded theory approach, which they connected to an adaptation of the statistical graph literacy framework discussed by Shaughnessy in his 2007 handbook chapter. That framework includes 4 components: reading a map, which refers to recognizing and interpreting a map's components; reading within a map, which refers to using a map to compare 2 places; reading beyond the map, or building a spatial argument by finding a pattern across more than 2 places; and reading behind a map, which is about interpreting causes of that spatial pattern. The team added a 5th component to the framework, entering a map, which refers to entering a space to gather data for a map. To account for evidence of political formation, Rubel and colleagues employed the definition offered by Sarah Elwood and Catherine Mitchell and drew methodologically from Rico Gutstein. They look for evidence of 3 things in their data: becoming individual political subjects by identifying unequal access to resources; linking the perspective of unequal access for certain individuals or groups to other, wider spatial processes; and building shared political understandings extendable beyond a specific classroom through actions and expressed orientations to share with and teach others about what was learned. In the article, the authors organized the reporting of the results according to the 5 components of the map reading framework: reading a map, reading within a map, reading beyond the map, reading behind a map, and, the one they added, entering a map. Regarding the first, Rubel and colleagues found 3 practices: finding self, visiting distant places, and noticing extreme values. Finding self, they argued, is a way for learners to position themselves in relation to the city and to relate individually meaningful places in spatial context, as they did on hands and knees on the floor map or with the GIS maps, finding their homes, their school, playgrounds, subway lines, etc. One student examined whether and how pawnshops were near her residence. Students noticed extreme values on GIS maps by examining the density of colored dots representing whatever they chose to visualize, levels of poverty, banks, etc. Through this, they discovered socio-spatial inequities. For example, one student, Rebecca, first noticed the density of banks in Manhattan, and then later, when examining a map in which density of dots indicated number of households per bank, she was shocked at how few there were in other neighborhoods. "What?" she exclaimed. "So East New York shares 1 bank?" Rebecca's example relates to a second component of the map reading framework, reading within the map, or comparing pairs of places. The authors found evidence of political formation within this practice as comparisons revealed unequal access to financial institutions. For example, in one activity, students compared the predicted and actual distributions of pawnshops. When the true distribution was shown on the floor map, it revealed that some boroughs, Queens and Staten Island, had significantly fewer pawnshops than the hypothetical number, whereas other boroughs, Manhattan and the Bronx, had considerably more. Students expressed their surprise and frustration with this difference and began to raise questions as to its origins and how things could be changed. Such questions moved them toward reading beyond and behind the map. Among the conjectures that the students raised was that there is an inverse relation between income and the number of pawn shops in a neighborhood. Discussions turned to explanations for why that might be, reading behind the map, and eventually turned to exploitative power structures, which students described in both economic and racial terms. The authors argue that such exploration solidified students' collective consciousness as they connected their lived sense of place to the insights that working with the mapping tools afforded. This is not to say that all students were all like-minded. For example, one student argued that pawnshops play an important role for individuals whose low credit precludes them from accessing bank services. Such sentiments were reflected in the students' experiences on their participatory mapping day, during which they visited the school neighborhood's banks, pawnshops, wire transfer stores, and check cashing stores, where they found the alternative financial institutions to be more welcoming than the banks and more transparent through required signage about rates and policies. Through this entering of the map, the students became political actors, and their stories, the authors write, quote, acted as instances, evidence, or counter-evidence to claims about the spatial justice of the two-tiered system, unquote. In debriefing the experience, students again asserted that race underlies this two-tiered system, and even pressed the white and Asian research team and teacher on their own financial preferences and practices. In the discussion section, Rubel and colleagues draw attention to the affordances of each of the spatial tools they employed and argue for how the combination and interplay of all three gave rise to opportunities for political formation. The floor map primes students to think about distribution of resources from an aerial, citywide view. The GIS maps help to coordinate data layers and confirm or disconfirm hypotheses. And participatory mapping, they argue, enabled learners to explore and share how and where this spatial justice issue impacts people. The authors conclude by highlighting limitations and point to a number of unanticipated developments as counsel for others interested in pursuing such work. For example, early in the paper, they also remind us that, quote, a study of how groups of people are systematically and have historically been underserved through place needs to be coupled with complementary looks at agency and resistance or opportunity of geography, end quote. They caution readers not to misinterpret systemic injustice as outcomes of people's deficiencies. For example, we should take care in comparative spatial analyses not to reinforce narratives of inferiority of marginalized people. It's also important to remember that places can change, that individuals have agency, and that there is great potential in political action. For listeners who are interested in learning more about this work, and important cautions to consider in particular, you might look up another of the author's papers in Harvard Educational Review entitled Teaching Mathematics for Spatial Justice, Beyond a Victory Narrative.
I'm Sam Otten from the University of Missouri, and although we usually focus on empirical studies here, I'm actually going to give a quick review of a new book that I just read, which was much more deductive than empirical. It's called The Calculus Story, A Mathematical Adventure by David Acheson, an applied mathematician from Great Britain. So the first thing I want to say about The Calculus Story is that it's definitely more like a story, not a textbook. That is to say, it's not a book that will help you develop proficiency in differentiating or integrating functions. Instead, its goal seems to be taking the reader on an enjoyable journey through some ideas of calculus. And Acheson is a worthy guide for this journey because his writing is smooth and comes across as quite effortless. He has also structured the book into very manageably sized chapters, so that you never really get bogged down, but instead you always have a feeling of momentum as you move through the text. Although this is not a calculus textbook, I can say that the book does have mathematical substance. It's just that the substance is much more conceptual than procedural. For example, he starts the book by very intuitively addressing the idea of a changing rate. This made me think of a couple things. First of all, I was reminded of our prior episode with Heather Johnson where we talked about increasing increases in the context of middle school math. Second, I was reminded of how many people talk about calculus as the study of change. But that definition is certainly too broad because many disciplines other than mathematics would say that they study change. Changing climate, changing demographics, changing language, and so forth. Thus, Acheson, I think, offers a good resolution when he says that calculus is the study of the rates at which things change. He continues by dealing with the idea of infinity and approaching infinity. And again, he uses intuition and visualization as a conceptual tool. moving through several results and building up some of the foundational elements of calculus, only much later dealing with the technicalities of the epsilon-delta definition of limits. And speaking of epsilon-delta, I must say that this book presented a great treatment of those technicalities on limits. He goes through a sort of Lakatoshian development where he starts with something that seems to make sense, but then he provides an example that pokes some holes in it, and then you refine that, poke holes, and refine that through a kind of cycle. So for example, what does it mean when we say y tends to 0 as x tends to infinity? Well, that means y gets closer to 0 as x increases. But then Acheson presents a new function to think about, a function that approaches 1 from above, for example. If it's approaching 1, it also is getting closer to 0 as x increases. So then we have to go back and revise our idea. Okay, so y tending to 0 means that we can make y as close to 0 as we like by taking a large enough x. This seems pretty good, but then Acheson throws in another function to consider. What about a function that approaches 0 when x is a non-whole number, but stays at 1 when x is a whole number? This one gets arbitrarily close to 0 as long as the large x that we choose is not a whole number. And then there's a few more steps in this refinement process, but what I like about it is that each step is intellectually motivated. So when you finally end up with the full epsilon-delta definition, it can hopefully make sense, rather than seeming like some arbitrary technicality from the mathematical community. Each part of that definition that you arrive at, you can see where it came from and what motivated it. I also like how just this chapter overall exemplifies the mathematical process of refinement and attending to the precision of our definitions and ideas. Although this book is quite fun to read, and I appreciate the brevity of 181 pages, there are a couple aspects that I think were underdeveloped. First was the role of applications. Now, there were several applications included in the book, but they tended to be very quick and usually after the fact, where they were used more to illustrate a purely mathematical idea rather than a full application that's representing something realistic. The examples are still very welcome, and they were well thought out, but if you're looking for truly realistic explorations of calculus ideas in the world, then this is probably not the right book for you. This book unabashedly revels in the beauty of the mathematical ideas themselves. The second thing that, out of personal preference, I wanted to see a bit more of was more acknowledgement of non-Western contributions to the development of mathematics. There was a quick mention on page 107 of the Indian mathematician Madhava, who is cited in relation to the series representation of pi over 4 as 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9, and so on. But the book still remains comfortably within the well-known Western narrative of Newton and Leibniz. I do appreciate that this book humanizes the subject matter, and including some of these human characters, plus the amicable way that Acheson himself writes, it shows that mathematics does not have to be entirely cold and free of charm, but I think it would have been good to go even further and show that mathematics is not only human, it also spans the full diversity of humanity. In closing, I just want to say who I think this book is ideally suited for. I think this is a great book for people who have a good foundation of algebra knowledge and who enjoy mathematical ideas but have never had a chance to study calculus. They will find this book accessible, and it will give them access to the big picture of calculus, which might be something they desire, and they have no need for the procedural techniques anyway, so this book should be right up their alley. The other group of people to whom I would definitely recommend this book is people who took calculus courses in the past, but in looking back, they feel as though those courses only taught techniques of differentiation and integration. If the underlying ideas and key insights always seemed missing or unclear, then I think this book can be a quick and enjoyable way to revisit calculus and gain some of that conceptual perspective. For me, it was a way to recreationally delve back into some good mathematics problems and ideas. I also want to say about Acheson's The Calculus Story that I love the last sentence. The book ends like this: I once played tennis with him in 1973. A bold final sentence, and if you're curious about who this sentence refers to, you can read the book to find out.